Okay, so this video is going to be a little bit different than the others. We're setting up something called linear operators. And in this section we're going to learn why linear differential equations are called linear. So if you've had Math 240, then you're going to know what I'm going to be talking about. Linear operators. In fact, the name of 240 is linear algebra, right? And the linear in linear algebra is the linear that we're going to be talking about here in just a minute. Okay, and so just to give you a little bit of background, when we write down a differential equation, so for example, suppose my differential equation is of the form y prime plus t times y equals cosine of t. The idea here is that if I take all the stuff that has to do with y and I think of this as I'm going to ask the question, what does this equation, or this side of the equation, left hand side, do to a function y of t? Well, if you look at this, in this particular case what we're doing is we take y of t, whoops, sorry about that, got excited there. I'm having some trouble writing on my tablet today. Take y of t and then differentiate it to get y prime. Then secondly, we're going to multiply y of t by t, and then we add those two things together. So in other words, what I'm doing to y in this operation here is that the differential equation, the dE, is performing these actions to a function y, right? So just for example, let me introduce a notation. So that means I'm going to, maybe I'll call this f. And so f of y then is going to be my operation for my differential equation. And in this case, f of y is going to be take the derivative and then add it to t times y of t. Notice that I'm just really just rewriting this left-hand side, right? But then what we can ask is, well, what does f do to other functions? What does f do to e to the t, for example? Well, f of e to the t is going to be e to the t, that's the derivative, plus te to the t, right? What is f going to be doing to, say, the cosine function? It's going to be minus the sine of t plus t times the cosine of t, right? And what does f do to, a constant function 3, for example? Well, f of 3 is going to be 0, which is the derivative of 3, plus 3t. Good. And so this is the operation of we can think of it as the action of our operation, right? And so I think we're ready for a definition now. By the way, in solving the differential equation, what are we doing? We're looking to see if any of those outputs of the function is equal to cosine of t. In this case, are any of these equal to the cosine of t? No. Therefore, we have not found the solution yet. But we can still act on the differential equation using what's going to be called the differential operator. And so let's define that. Given a differential equation, the operator associated with that is found by moving everything with y in it. Those are quotation marks, right? Those are not derivatives. So that means y prime, y double prime, etc. to the left-hand side of the equation, and everything else to the right-hand side. Then what's left on the left? What's left on the left-hand side? Sorry about the language I'm using there. Of the equation is the operator or the action for the differential equation, for the DE. So you might notice we're using the operator in a kind of a new way here. An operator is a function whose input is some set of functions. Okay, and so the differential operator we're going to be thinking of it as the operator associated with the differential equation. The operator associated to a differential equation. Okay, so let's do an example. Y prime plus y double prime equals y cosine of t plus t squared. We want to find the operator. Well, we said move everything with y to one side of the equation, so we're going to move that one over, and we're going to have y times y double prime plus y prime minus cosine of t, I should put cosine of t first, times y equals t squared. Okay, and so the idea is that you're going to ignore the right hand side. That doesn't have anything to do with y, and what's left on the left hand side is going to be your operator. So this is going to be your f of y. Okay, and so this is telling us what to do with our f, right? Or what to do with our y. So what this is saying in this particular example is I'm going to take a function y and I'm going to multiply it by its second derivative. Then I'm going to add its first derivative minus the cosine of t times the original function. And if I do all those computations, I'm going to be left with a new function. Okay, and that's going to be the output of your operator. Good. So that is what we're looking at for our differential equations, is differential operators. Just as another example, here's a special operator. We've been already working with it, but the operator D is sometimes, the letter D is sometimes used for an operator. So if we define d of y to be a function, and that function inputs a function y and outputs the derivative with respect to t, right? That's called the derivative operator. I will call it derivative instead of differential. Derivative operator. So therefore, what is d of e to the 2t? That's 2e to the 2t. What's d of t squared? 2t, and so on. D of cosine of t, cosine of t minus the sine of t, and so on. Good, okay. And similarly, d of y could be abbreviated as d with a 2 there, and that is going to represent the second derivative. And so d2 of something like e to the, oh, that looks like a minus sign, e to the 2t would be the second derivative of e to the 2t, right? And so here's our first derivative, so our second derivative would be 4e to the 2t. Good. All right. So that's kind of a special operator, is the derivative operator. Good. Now we're ready for our big definition of the day. Definition. Definition. I don't need to type in. Definition. An operator we'll call it f for now, is said to be linear if two properties hold. If two properties hold, and that is, let me say f of, I'm going to use function notation because remember that operators, the input to an operator is a function. So if I take an operator on a sum, that is the sum of the operators. And if I take the function or the operator of a constant times a function, that's a constant times, I'm getting ahead of myself, the operator applied to f. Good. So example, f of y equals d of y. So is that true? Is the derivative a linear operator? Well, d of, let's say, y1 plus y2. How do we differentiate a sum? It is the sum of the derivatives, right? And that is d of y1 plus d of y2. Furthermore, if I take the derivative and apply it to c times y, we know that we can pull the constant out, right? So that's the constant times d of y. Good. So therefore, the derivative is a linear operator. D is a linear operator. Very good. Okay, I think I'm going to stop here, and we're going to continue this in the next video. So we're going to look at properties of linear operators that make it really nice to work with the linear operators. See you then.